Okay, so we've all heard about how these LLMs are supposed to be like, total math geniuses, right? Like they're going to be balancing our checkbooks and doing our taxes.
Well, maybe not quite yet.
Right. But it's a fascinating topic. And this research paper we're diving into today, GSM Symbolic, Understanding the Limitations of Mathematical Reasoning in Large Language Models, really digs into how well these models actually think about math.
Yeah, and it gets kind of deep. Like, do they really get it, or are they just good at, spotting patterns?
Exactly. Like, are they actually understanding the math or just mimicking what they've seen before?
Right. So researchers have been using this thing called the GSMAK benchmark to try to figure that out. It's basically a bunch of grade school level math problems, like word problems.
Yeah, those. I remember those. Like, remember Sophie and the toys? Sophie buys 48 toys for her nephew. She gets some building blocks, some stuffed animals, and stacking rings. Then she adds some bouncy balls to her haul, bringing the total to 62 toys. How many bouncy balls did she buy?
Exactly. That kind of thing. So they use these problems to see how well the LLMs can reason mathematically.
Makes sense. So how'd they do? Are they passing with flying colors?
Well, GSMAK has been helpful, but it's got some limitations.
Oh, like what?
Well, since it's always the same set of problems, there's a chance the models might have already, seen them during training. You know what I mean?
Ah, so they might already kind of know the answers. That wouldn't be a very fair test then.
Exactly. Plus, it doesn't really show us how they're actually getting to the answer,
Yeah.
just whether they got it right or wrong.
So how do we get a better picture of what's going on in those AI brains?
Well, that's where GSM Symbolic comes in.
Yeah.
This new benchmark is pretty clever. Instead of using the same problems over and over, it uses these templates to generate a ton of different variations.
Oh, okay. So like same math, different story.
Yes. Exactly. They can change the names, the numbers, the objects in the problem, but the math behind it stays the same.
So it's like giving the same test, but with different wording each time to see if they can still solve it.
Exactly. And what they found was just by changing the numbers.
Wait, just changing the numbers messed them up.
Yeah. Performance dropped like an average of 20% across the board.
Whoa, hold on. If I gave a student the same math problem, but just with different numbers and they suddenly couldn't solve it, I'd be a little concerned, you know?
Right. And that's what's so interesting here. It suggests that these models might be relying more on recognizing those patterns from their training data than actually understanding the math itself.
So they're good at recognizing problem types they've seen before. But when the numbers change, they're like, wait, what?
Pretty much. It's like they're not generalizing their knowledge very well.
Okay, so changing the numbers threw them off. But what about making the problems more, I don't know, complicated, like adding more steps or something?
Well, that's what the researchers did next. They started adding or removing these things called clauses from the GSM symbolic problems.
Clauses. Remind me what a clause is again.
It's like a part of a sentence with a subject and a verb. Think of it like a recipe.
Okay, yeah, I get it. Like a recipe with more steps is harder to follow.
Exactly. More clauses, more steps, tougher to follow.
So adding more clauses to a math problem makes it harder to digest. Got it. What happened when they did that?
Well, the more clauses a problem had, the worse the models did.
Yeah.
And get this, their performance also got less consistent.
So double trouble. They were getting more answers wrong. Andy, it was harder to predict how well they'd do.
Exactly.
Hmm. That is interesting. Why do you think that happened? Like, was it just too much information for their AI brains to handle?
Well, it's possible.
Yeah.
It could be that the added complexity just kind of overwhelmed their ability to process the info and apply the right steps.
Yeah.
Like trying to cook a complicated dish without following the recipe carefully.
Okay. Yeah, that makes sense. Things can definitely go south quickly in the kitchen if you don't follow the recipe. But wait, they didn't stop there, did they? There was something about, like, adding irrelevant information to the problems too, right?
Yeah. Yeah. They took things even further with this thing called GSM Noop. And it's pretty wild. Imagine adding a bunch of information to a math problem that sounds like it's important, but it actually has nothing to do with the solution.
Like what? Give me an example.
Okay, so picture this. Oliver picks 44 kiwis on Friday and 58 on Saturday. On Sunday, he picks double the number from Friday, which is 88. But, and here's the catch, 5 of the kiwis he picked on Sunday were smaller than average. How many kiwis did he pick in total? See, they snuck in that detail about the smaller kiwis.
Ah, sneaky. But that doesn't change the total number of kiwis you pick.
Exactly. But a lot of the LLMs fell for it. They got all hung up on that irrelevant detail and started subtracting those 5 smaller kiwis, even though it didn't make sense.
Wow, that's kind of like how we humans get distracted by shiny objects sometimes.
It is. And it's fascinating because it shows that even these powerful AI models are susceptible to being misled by irrelevant information. And the results were pretty dramatic.
How bad did they do?
Well, their performance tanked. Accuracy dropped by like up to 65% in some cases.
65%. That's huge. So maybe these so-called math whizzes aren't as smart as we thought after all.
Well, hold on. Let's not write them off just yet. These models are still incredibly capable. They can do some amazing things. But this research just shows that when it comes to math, they might not be thinking exactly the way we do.
Right, they're not little human mathematicians in a box.
Definitely not. They're more like, well, maybe math-loving parrots.
Okay, a math-loving parrot. I like that analogy. But before we get too carried away with that, let's talk about some specific LLMs, the ones from OpenAI, called O1 Preview and O1 Mini. They seem to be the, I don't know, overachievers of the AI math class, right?
Yeah, those O1 models are really interesting. They consistently did better than other open models on both the GSM-8K and GSM symbolic benchmarks.
So what's their secret? Do they have some special training regimen? Are they eating AI brain food or something?
Hard to say for sure. OpenAI is pretty secretive about their methods. But it's probably a combo of things. Better training data, more sophisticated algorithms.
So they're like the gourmet chefs of the AI world. But even these top-performing O1 models, they weren't immune to the GSM NeurOp challenges, right?
Right, even they got tripped up by that irrelevant information, though their performance didn't drop as dramatically as some of the other models.
So even with all their fancy algorithms and training, they still struggle with really understanding context and filtering out the noise.
Yeah, seems like it.
Okay, that's both kind of reassuring and a little scary at the same time. It means that even the best LLMs out there still have room to improve. But before we dive into all that, let's take a step back and think about what these findings actually tell us about, understanding in AI. Like, what does that even mean?
Yeah, it really makes you think, doesn't it? Like, these models can do all these incredible things, but then they get tripped up by something so simple. Makes you wonder if we're even using the right word when we talk about them understanding something.
Right, like maybe it's not really understanding, it's something else. What do you think? Is there a better way to describe what's going on in those AI brains?
Well, that's a question that's been bugging philosophers for centuries. I mean,
Yeah.
what does it really mean to understand something? And we're not going to solve that here today, but I think this research does give us some, food for thought. It suggests that understanding, real understanding, it's not just about processing information. It's about connecting that information to a bigger picture.
Okay, yeah, it's not just about knowing the answer, it's about knowing why that answer is right and how it fits into everything else.
Exactly. It's about making connections, drawing inferences, being able to apply your knowledge to new situations. And that's where these LLMs, at least the way they are now, seem to fall short. They're amazing at recognizing patterns, but they haven't quite cracked the code on that deeper level of understanding that we humans have.
But don't humans get fooled by irrelevant information too? Like we all have our biases, right?
Right.
We make assumptions, we jump to conclusions.
Oh, absolutely. Humans are far from perfect. We definitely have our quirks and blind spots. But I think there's a key difference here. When we make mistakes, we can learn from them, right? We can change our thinking. We can question our assumptions.
We can update our mental software.
Exactly. But these LLMs, they seem to be stuck in this kind of pattern matching loop. They're not really learning and evolving in the same way we are.
So we're constantly learning and adapting, and they're kind of stuck in their ways. Okay, so we need to teach these AI models to be more like us, to think critically, to question what they know, maybe even have a little existential crisis now and then. But how do we actually do that? Is it even possible to build a machine that can truly think like a human?
It's a tough question, a really tough question. But there are some really smart people working on it. And one approach they're exploring is to, incorporate more structured knowledge into these LLMs. Right now, they're mostly trained on massive amounts of text, which is great for learning language, but not so great for developing a deeper understanding of, how the world works.
It's like they're reading a million books, but never actually going outside and experiencing life firsthand.
Exactly. To really get concepts like math, they need to be able to connect those abstract symbols to real-world stuff, like
Sure.
objects, relationships, quantities.
So instead of just crunching numbers, they need to understand what those numbers actually represent.
Right. And that might involve going beyond just text.
Yeah.
We might need to incorporate visual information, simulations, even interactions with the physical world.
Like give them hands-on math lessons instead of just textbook problems.
Yeah, something like that. And another interesting approach is to develop models that can reason more symbolically.
Symbolically, what does that mean?
It means like manipulating symbols and concepts in a way that's more similar to how humans think.
So instead of just seeing numbers as data points, they'd be able to understand them as like abstract entities with properties and relationships.
Exactly. And that would allow them to do some pretty sophisticated reasoning, like make inferences, draw analogies, solve problems in a more flexible way.
Wow. Okay. So we're talking about a whole new level of AI here, one that goes beyond just pattern matching and into like true understanding. But doesn't that bring us back to that initial question? What does it actually mean for a machine to understand something? Like, are we just chasing some, I don't know, philosophical unicorn here?
Maybe. It's a question that might not have a clear answer. But I think this research helps us to think about it in new ways. It shows us that understanding isn't just about information processing. It's about connecting that information to a larger context, making inferences, adapting what you know to new situations.
So it's about more than just knowing the answer. It's about knowing why and how it all fits together. And it sounds like that's a level of sophistication that these elements haven't quite reached yet, even though they're already doing some pretty impressive things.
Yeah, I think that's fair to say. But that doesn't mean we should give up on the idea of building truly intelligent machines. It just means we need to keep pushing the boundaries, exploring new approaches, and keep asking those tough questions.
Okay, but all this talk about pushing boundaries and exploring new frontiers in AI, it makes me wonder if we're focusing enough on the potential risks. Like, what could go wrong here?
That's a really important point, and one we definitely can't ignore. As we develop these increasingly sophisticated AI systems, we absolutely need to think about the potential downsides. It's not just about making AI smarter, it's about making sure that intelligence is used responsibly and ethically.
Right, right. It can't just be a race to see who can build the most powerful AI without thinking about the consequences. It's like giving a toddler a chainsaw. Sure, they might be able to cut some wood, but the risks are just too high. So where do we even start with this whole ethics thing?
Well, I think one crucial area is accountability, right? As these AI systems become more autonomous, more capable of making decisions that impact our lives, we need to figure out who's responsible when things go wrong.
Yeah, like what happens if an AI system causes harm? Who's to blame? The developers, the users, the AI itself? It gets pretty tricky.
Yeah, it does. And these questions are only going to get more complicated as AI becomes more intertwined with our lives. We need to develop clear laws and guidelines for AI development and use.
So it's not just about the tech itself, it's about the whole system around it, right? The laws, the regulations, the social norms. We need a framework to make sure AI is used safely and ethically.
Exactly. And that's going to require a collaborative effort. We need researchers, policymakers, industry leaders, even the general public, all working together.
So we all have a role to play here. We can't just sit back and watch this happen. We need to be active participants in shaping the future of AI.
I completely agree. This deep dive has been a fascinating exploration of both the possibilities and the potential risks of AI.
Yeah, and it's shown us that even in its most advanced forms, AI is still a reflection of us, our ingenuity, but also our flaws.
It's a powerful tool, but like any tool, it can be used for good or for bad. And it's up to us to make sure it's used for good.
Okay, so big question here for everyone listening. What can you do to help ensure AI develops responsibly and ethically?
Well, first and foremost, stay informed. Read about AI, engage in conversations, ask questions. The more you understand about these technologies, the better equipped you'll be to make informed decisions.
Right, knowledge is power. Don't just passively consume whatever AI-generated content is thrown your way. Think critically about it. Question it.
Exactly. And don't be afraid to speak up. Share your concerns, advocate for responsible AI development, and demand transparency from the people who are building and deploying these technologies.
We all have a voice in this. We can be passive bystanders, or we can be active participants in shaping the future of AI. And I think we all know which one is better.
I couldn't agree more. The future isn't something that just happens to us. It's something we create.
That's a great point. And on that note, I think it's time to wrap up our deep dive. We've covered a lot of ground today, from the technical details of how LLMs work, to the surprising limitations they have with math, to the really big ethical questions surrounding AI.
It's been a great conversation. Hopefully you're walking away with a better understanding of this rapidly evolving field.
And if you're feeling a little bit overwhelmed, maybe even a little bit concerned, well, that's okay. It means you're thinking about these things.
Exactly. That's what we want, to spark curiosity, get people talking, and encourage responsible engagement with this incredible world of AI.
So until next time, keep exploring, keep questioning, and keep diving deep.
Yeah, it's kind of a mind-blowing concept, isn't it? That these AI models can be so complex and so unpredictable sometimes. But all this talk about pushing boundaries and, exploring new frontiers in AI, it makes you wonder, are we paying enough attention to the risks?
Oh, for sure. That's a really important point. We can't just ignore that. As we build these, more and more powerful AI systems, we really have to consider the potential downsides. It's not just about making AI smarter, it's about making sure that it's used, well, ethically, responsibly.
Right. Like it can't just be a race to build the most powerful AI. We have to think about the consequences.
Right.
It's like giving a toddler a chainsaw.
You're right.
I mean, yeah, they might be able to cut down a tree, but
Yeah.
probably not a good idea.
Not a good idea.
So where do we even begin with addressing, like, the ethical side of all this?
Well, I think accountability is a good place to start. As AI systems become more autonomous, more capable of making these decisions that impact our lives,
Right.
we have to figure out, like, who's responsible when things go wrong.
Yeah, that's a big one. What happens if an AI system makes a bad decision,
Yeah.
causes harm? Who's to blame? The developers, the people using it, the AI?
Exactly. Yeah, it gets complicated fast. And as AI becomes more, integrated into our lives, these questions are going to become more and more important. So we need to think about clear laws, guidelines, ethical frameworks for developing AI and using it responsibly.
So it's not enough to just focus on the technology itself.
No.
We need to think about the whole system around it, right? Laws, regulations, social norms. Absolutely, yeah. We need a framework to ensure that AI is used safely and ethically. And that's going to require a lot of collaboration, I think. We need everyone involved: researchers, policymakers, industry leaders, even the general public.
So we all have a role to play here.
We do.
We can't just sit back and let things happen. We have to be involved, right? We have to help shape the future of AI.
I agree, yeah. This deep dive, it's been a really interesting look at both the incredible possibilities and the potential risks of AI.
It really has. And it's shown us that even at its most advanced, AI is still a reflection of us, our ingenuity, our creativity, but also our limitations, our flaws.
Yeah.
It's a powerful tool, but it's a tool that can be used for good or for bad. And ultimately, it's up to us to choose.
That's right.
So for everyone listening, what can you do to help make sure that AI is developed and used responsibly and ethically?
Well, I think the most important thing is to stay informed. Read about it, engage in conversations, ask questions. The more you understand these technologies, the better equipped you'll be to really make informed decisions about their role in our world.
Right. Knowledge is power, as they say.
Yeah.
So don't just take everything you hear about AI at face value, right? Think critically, question things, and don't be afraid to speak up.
Exactly. If you have concerns, share them. Advocate for responsible AI development. Demand transparency from the people who are building these technologies. We all have a voice in this.
Absolutely. It's up to all of us to shape the future of AI. We can't just sit back and watch it happen.
I agree. The future isn't something that just happens to us. It's something we create.
That's a really powerful thought. And on that note, I think it's time to wrap up our deep dive for today. We've covered a lot of ground, from the really technical nitty-gritty of LLMs to the surprisingly tricky relationship they have with math, and of course, the big ethical considerations surrounding AI.
Yeah, it's been a great conversation. And hopefully you've learned something new today about this exciting field.
And if you're walking away with, more questions than answers, that's okay. That's a good thing. It means you're thinking about this stuff. It means you're engaged.
It does. That's really all we can ask for. To spark some curiosity, get people talking, and encourage, responsible and thoughtful engagement with this amazing world of AI.
So until next time, keep exploring, keep asking those tough questions, and of course, keep diving deep.